Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here is information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. And all of these internet addresses or URLs, URL means Uniform Resource Locator, have this acronym BTDT in them. That's the brand name I use, and it stands for Been There, Done That, because if you want to pass actuarial exams, when you take the exam, every time you look at a problem, you should be able to say, been there, done that, so that you clearly know what to do immediately. You don't have to think about it. You've done so many problems of this type that you know immediately what to do. If you have to think what to do, you're not prepared. Thinking is the last resort of the unprepared. So prepare so that every time you look at the problem, you immediately know what to do. You should be able to say, been there, done that. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. An insurance policy pays $100 per day for up to 3 days of hospitalization and $50 per day for each day of hospitalization thereafter. The number of days of hospitalization, x, is a discrete random variable with probability function. Probability that x is equal to k equals 6 minus k over 15 for k equal to 1, 2, 3, 4, or 5, and the probability function is 0 otherwise. Calculate the expected payment for hospitalization under this policy. And here's the solution. Let us write y for the insurance payment. Then y is equal to 100 times x for x equal to 1, 2, or 3. And then 300 plus 50 times x minus 3 for x equal to 4 or 5. And the expected payment is e of y, which is 100 times 1 times 6 minus 1 over 15. The payment is 100 times 1 because it's only 1 day at $100. And the probability of being 1 day in the hospital is 6 minus 1 over 15. Then if it's 2 days, it's 100 times 2 times 6 minus 2 over 15, because 6 minus 2 over 15 is the probability of being in the hospital for 2 days. Then it's 100 times 3 times 6 minus 3 over 15, because 6 minus 3 over 15 is the probability of the patient being in the hospital for 3 days. For the fourth day, the first 3 days are paid at $100 each, that's 300, and the additional day is paid at 50, so it's 50 times 4 minus 3, that's the payment for that fourth day. And that's a total of 350, by the way, of course, and that's multiplied by 6 minus 4 over 15, which is the probability of the patient spending 4 days in the hospital. And then for 5 days, it's 300 plus 50 times 5 minus 3, so it's really a total of 400, times 6 minus 5 over 15, which is the probability of the patient spending 5 days in the hospital. And once we calculate all that, that's equal to 220, which is answer C. And please remember this is copyrighted material. The problem itself comes from the Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.